Hey, welcome everybody to Metabolism 1.3, evaluating initial claims about ELISA. Now, there are a number of things that we're going to be doing in today's lesson and some new tools that you're going to be introduced to. Right away, you're going to be introduced to one in the warm-up. For the warm-up, I'll go ahead and actually, go there. Ta-da! Students explore and get familiar with the Metabolism Modeling Tool. Let's talk about this modeling tool. It says the metabolism modeling tool is a tool you will use often to show your thinking about how the human body works. Here's the tool right here. And basically what it is, it looks kind of like the simulation, doesn't it? But differently than the simulation, you can take molecules from over here and you can put them wherever you think they go. For instance, I just put some water molecules in the heart. Is that where water molecules go? I don't think so. Reset, there you go. What are you supposed to do here, though? Spend the next few minutes trying out different things. Try to get familiar with the modeling tool, move the molecules around, and then press hand in on the modeling tool, and you should see a screenshot of it here below. There are actually, there's a menu over here. Don't mess around with this yet. We will use this in future lessons. For now, just go ahead and move around the molecules and see what you can do with that, okay? Do that, press hand in, and then come back to me. Okay, the next thing we're going to be doing is we're going to be reading about some of these molecules. We're going to be learning about them. So the reading is molecules cells need. So if you are in Amplify, you're going to be on activity 2 here. And ta-da, open the article molecules cells need. You can access it that way, or you can access it in the Amplify library itself. Both ways. So in the sim, we observed that in a healthy body, cells get certain molecules from food and air. Let's review some of the words we saw in the sim and their definitions. Let's actually jump to the sim again really quick. So we saw that, yes, the body needs these molecules. These molecules are going all around. Some of them come from air. Some of them come from food. Hey, hint, these are your lungs over here. This is representing your lungs, and this is representing your stomach over here. So we can see these oxygen molecules coming into your lungs. And let's see, fish. Ooh, food molecules are going to go over here into your stomach, okay? So let's go back to the slides really quick. Let's review some of the words we saw in the sim and their definitions. First one is molecule. We've been talking about this. Molecule is a group of atoms that are joined together in a particular way. When we did the scale tool, we saw that molecules were incredibly small. When we were talking about microorganisms and microbiomes, we said that molecules are way, 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 way smaller than even cells, okay? Here's another one, glucose. Glucose is a molecule. It's a type of molecule. It's a molecule that organisms use to release energy that is made of carbon, hydrogen, and oxygen atoms. Glucose is your body's favorite way to get energy. We also have oxygen, a molecule that organisms get from the air or water around them and use to release energy. You've probably heard of oxygen before. You know that your body needs oxygen, okay? And the next one, amino acids, molecules that are the building blocks of protein. Amino acids are almost like little Lego pieces that you can build proteins with. And then guess what? You can take those proteins apart. You can build something new with your amino acids. You don't always have to build the same thing. But amino acids, building blocks of protein. So we're going to read an article. We've talked about active reading before, and we said active reading is when you are annotating your article, you're thinking about what you're reading. You're not just reading it so you can say, okay, I'm done reading, but you're actually thinking about it. You're trying to learn from it. You're highlighting, you're underlining, you're circling things. And you can do that electronically on the article in Amplify. So do that, read and annotate the article, molecules cells need, and then once you finish that, come on back to me. So you read the article by this point, and you have some annotations. Like we've done before, we want you to add these hashtags to the annotations. So if there's something that you would like to share with a partner, which you don't necessarily have, but maybe you could contact somebody in the class, go ahead and hit share. Hey, you could even email me if you wanted to. And then discuss, if you've discussed it already, you can put hashtag discussed next to it. Now, last time, and it doesn't show up this time, I'm not sure why, it had also present if you wanted to bring up something to the whole class when we actually talk about the article. You could do that too if you'd like. Here are some questions here that we want to focus on. Where does the body get glucose? Where does the body get amino acids? Where does the body get oxygen? And what it wants you to do, what Amplify wants you to do, is go back and actually highlight the parts of the article that answer these questions here. And this one also, what do you think could happen if the human body doesn't take in one or all of these molecules? Why do you think this? So try to answer that question as well. There isn't a place for you to actually type out your answers in Amplify, but I do want you to go back and highlight in the article where you can find the answers to these questions. So go ahead and do that right now. Go ahead and pause and do that. The next thing that we are going to do is we're going to model a healthy cell and model the molecules that we would expect to find in a healthy cell. So in Amplify, you are going to click on this in 1.3 molecules in a cell. This is activity 3. And it looks like this is what should pop up. So the slides, it says, before we can diagnose Elisa, we need to understand more about what's happening in a healthy body. We'll make models to show which molecules are found in a healthy cell. So again, the first thing we're trying to do is show like, well, what does a healthy body look like? What does a healthy body need? And then we can better understand, okay, well, what is Elisa's body not getting? That's where we're headed with this, okay? So we're gonna use this modeling tool. Scientists often use models to work out their ideas and share them with others. Is a cell this big? No, a cell is not nearly that big. However, enlarging it and drawing it in such a way could help us understand better what is actually going on in a cell that we wouldn't be able to understand in another way. So let me go ahead and show you some of the things that you can do. Very much like the modeling tool we used in the beginning, it has some molecules, and what you're going to do is you're going to show which molecules should be found in a healthy cell. So you can drag and drop. When you are done, make sure you hit this hand in button right there so that I can see your work. So go ahead, take some time and work on that right now, and then come back to me. Well, check it out. It's our first key concept for this unit, and it says a functioning human body has molecules from food, glucose and amino acids, and molecules from air, oxygen, in its cells. Are those the molecules that you put into the cells in the human body and the model that we just completed? Because there's the answer right there. These are the key things that we want to show, that there is food, glucose and amino acids, and oxygen in each of the cells. So next thing we're going to do, we're going to evaluate some evidence, and we have this nice evaluation sorting tool that we didn't have last time that's going to help us. Let's read this letter first from Dr. Walker, the Walker doctor. Two medical students from Dr. Walker, MD, subject Elisa Rodriguez. As you know, we are trying to diagnose why Elisa Rodriguez is so tired. We're running some tests on her. We also asked her parents to keep journals to record her eating and sleeping patterns. We want to know if the cause of her problems may be lack of sleep or not eating the right foods. Boy, wouldn't that be nice? If that's all it was, hey, you know what? You just need to sleep more. Oh, well, great. I will do that. Hey, you need to eat these foods as opposed to maybe these foods. Okay, great. That would be a nice, easy answer. It's probably not the easy answer. We're probably going to have to do some more research, but wouldn't that be nice? We've just received the first of a set of evidence from Elisa's journals. We need you to evaluate the quality of this evidence to see if it can help us understand what is wrong with Elisa. If the evidence is not high enough quality, we may not be able to use it. Okay, so coming back again to evaluating evidence. Evidence is higher quality when it is based on more data because there can be more confidence in the patterns seen in the data. Let's look at an example of this. Here we go. We're going to do a practice round with two pieces of evidence that don't have to do with Elisa, and we're going to see which one is a higher quality. So here are the two pieces of evidence. Let's see. Is there a better way to view these? And here they are. We have evidence card A and B. I'm in activity 4 in Amplify. Evidence card A says, John observed his 14-year-old brother's sleep for one night. His brother slept for 10 hours. Based on this, John concluded that all 14-year-olds need 10 hours of sleep a night. Make sense? Or does it? Let's look at evidence card B. Scientists observed the sleep of 2,000 healthy 14-year-olds every night for a month. Okay, the average number of hours the 14-year-olds slept was 9.4 hours. Based on this, the scientists concluded that 14-year-olds need about 9 hours of sleep a night. So let's take a look at this. What we are supposed to do is we're going to say, well, which piece of evidence is higher quality evidence? What do we mean higher quality evidence? Well, what did we just say? Evidence is higher quality when it is based on more data because there can be more confidence in the patterns seen in the data. So if it's higher quality, we would put it up here at the top. If it's lower quality, we would put it down here at the bottom. I hope it's pretty obvious which one of these is the higher quality and which one is the lower quality evidence. Watching your brother sleep for one night is not providing a whole lot of data. What if he had watched his brother sleep for an entire year? Well, that would give us a lot more data. But what would we be missing? We would be missing other healthy 14-year-olds, wouldn't we? So we would know how much sleep John's brother needed. We wouldn't necessarily know what all 14-year-olds need or what is average. So the more data you have, the higher quality the evidence is. So what you're going to do is you are going to go through all of this data that Elisa has provided us, and you're going to sort it on the evidence tool. Let me find that for you, show you where it is. So if we're in number 4, you click on number 2 down here. You're going to click this, evaluating evidence, and I think it's this. Yes. So we have all the evidence over here on the right, and you're going to read through it, and you're going to decide how quality is the evidence, and then you're going to drag it. You're going to drag it over onto the evidence tool. So again, higher quality goes at the top, lower quality goes at the bottom. Once you finish, click hand in so that I can see your work, and then come back to me. Hey, let's take a look at some of these. So I sorted these based on kind of where I thought they might go. You might have some other ideas, but let's talk about this. So evidence card A, Elisa's sleep journal shows that she has gotten on average 9 hours of sleep each night for the past month. Okay, so she has been keeping that journal for an entire month. That's a lot of data. Let's look at that as opposed to evidence card B. The night before she came back to the doctor's office, Elisa slept 7 hours. So we have one piece of evidence that is showing us her amount of sleep over an entire month versus another piece of evidence that's showing it just for one night. Clearly, evidence card A is giving us a lot more data, much higher quality evidence than evidence card B is. Let's look at C. Elisa was asked to keep a food journal for a month. Her diary shows that over that month, Elisa ate between 6 and 8 servings of food that contained starch every day. She ate between 2 and 4 servings of food that contained protein every day. Okay, this is good. Again, we're getting an entire month worth of data here, and we see how many average servings of these different foods that she's getting. So I would put this up here towards higher quality evidence for sure, as opposed to evidence card D, which is very similar to like A and B. Elisa ate a lot of starch yesterday, but she still felt tired. Well, this is good information. We see that she ate a lot of starch one day, but still felt tired. But again, it's not giving us a ton of data. What if she ate a lot of starch or didn't eat a lot of starch the next day, but still felt tired? We like to have data over a longer period of time. Evidence card E. On the day before she started to keep her food and sleep diaries, Elisa said that she always felt tired, but she ate well and slept a lot at night. So this is giving us basically all the information previously to her food journals. She's saying, well, I slept well, I ate well, but it doesn't give us what? It doesn't give us a whole lot of detail. So we're seeing that, okay, she felt tired. She said she's getting enough sleep. She said she's, eating well, but we don't have a lot of details about that. So I wouldn't put it like high up. I might put it somewhere in the middle because it is lacking that detail, even though it gives us information over who knows how long a period of time. Okay. Getting close to the end. This is a longer lesson. Thank you for sticking with me. We're going to evaluate some claims about Elisa. Let's go ahead and take a look at what those are. Here we go. Elisa is feeling tired because she is not getting enough sleep. That's one idea. Another idea is she's not eating enough food or not eating the right foods. And another idea is that maybe she has a medical condition. So we're going to take a look at her journals and evaluate these claims. The first one, take a look at this. Average teenage sleep patterns. Many scientific studies of teenagers show that the most healthy teenagers get between 8 and 10 hours of sleep each night. Okay? Elisa's sleep journal shows that she's getting about 9 hours of sleep every night. So, based on this information, how do you feel about that? Do you think that her tiredness is because she's not getting enough sleep? Doesn't seem like it. Seems like she's getting right in that sweet spot between 8 and 10 hours of sleep. Let's look at this next one. Eating habits. A scientific study done on 1,000 healthy 14-year-olds found that they ate between 5 and 8 servings of starch per day and between 1 and 4 servings of protein per day. Let's look at Elisa's food journal. She ate between 6 and 8 servings of food that contained starch every day. 6 and 8 servings of food that contained starch, between 5 and 8 servings of starch, okay. And she ate between 2 and 4 servings of food that contained protein every day. It looks like Elisa, again, is fitting right into that healthy average of 14-year-olds for her eating habits. So it looks like a lack of sleep and poor eating habits do not explain her tiredness. So what we're going to do is we are going to be focusing on whether or not she has a medical condition. We're going to explore some of these medical conditions. We're going to look at what's going on in Elisa and try to identify, using the simulation, why she might be feeling tired. Let's move on to the homework now. For the homework, you are going to be trying to organize these or categorize these molecules in terms of their size. What are the biggest molecules? What are the smallest molecules? And you do that in Amplify. It allows you to just move them up and down in which order you think they go. So, oh, look, I think that one goes there. I think that one goes there. Smallest molecules at the top, largest molecules at the bottom. It's okay if you're not sure. And then here we go. Do you think these molecules are larger or smaller than a cell in the human body? Explain your answer. Explain, please. And you can go ahead and use the scale tool. Hey, there's another link to it right there from last unit if you want some help with that. After you do the homework, last thing, self-assessment. It says optional. Is it optional? No, it's never optional unless I tell you. And what I want you to do is I want you to answer all of these questions. These are for you to just evaluate yourself, hence self-assessment. These are some of the questions that we're trying to answer in this unit, some of the things that we're trying to understand. And so I want you to just see where you're at this point. Some of the stuff we may not have covered yet, and that's okay. You would click the not yet button, but still explain what you can here. Always, always, always try to write something in the explain your choice. If you say yes or if you say not yet, still explain. And don't just put IDK. Don't just put we haven't learned that yet. Can you explain anything about the question or the statement? I understand what molecules Elisa cells need and where they come from. I don't understand that yet. Well, maybe you understand something about molecules. Maybe you understand something about cells. Write that down here, okay? Don't just put we haven't learned that yet, all right? Try to come up with something that you do know that you can write down here, all right? After that, people, you are done. Big lesson today. So good job, and I'll see you next time.